Hello everyone. Today we are going to talk about how to use vExploder for reconstructing patient-level survival data from published Kaplan-Meier plots. On the front page of vExploder, you have the option to open the documentation, which I can definitely recommend, or you can directly launch the app. After having launched the app, you find a set of options here in the middle of the page. You can either create a new project or open a pre-existing project from disk, or you can load the sample project provided by vExploder. If you're not familiar with the process, I can recommend to have a look at the sample project. It has two survival cohorts shown in one figure, and all the provided methods of data reconstruction have been used on these cohorts, and so it may come handy to have a look on how reconstruction works with the app. We'll close this for now and start with a new project. You can either click on Create New Project here, or you go to the top menu bar and select Project, New Project. We can rename the project by clicking on the title to the top left and typing it whatever we want. We will call it Sample Project for now. Click on the Change button, and here we are. The first thing we have to do is to load the image file from which we want to reconstruct data into the application. We'll open the File Explorer and select the image we're going to work with and drag it into the browser window. As you can see on the left in the project outline, this has created a new figure inside of this project. We can give it another name by clicking on the menu symbol here and select Image Settings and just type in a new name. I will choose Figure 1 for this tutorial. You can also use the file picker input here to upload another image file for this figure. In the next step, we have to configure the axis. You can see in the axis of the original image that the time goes from 0 to 60 months and survival from 0 to 1 on the left. Internally, vExploder will use an own set of axes which have to be aligned with these original axes. You can see the vExploder axis by looking at the bottom of the figure and to its left. But what we are going to do is select the Move Axis tool by either clicking on the figure menu in the project outline and select Move Axis, or by selecting the Move Axis tool from the bottom toolbar. If you're using another tool in vExploder instead of the hand tool, which allows you grabbing and dragging the canvas, if you're using another tool, you can still move in the canvas by using the right mouse button to drag it. So what we're going to do is we will take the handles for axis alignment and just place them where the axis end or start in the original figure. I recommend to do it rather approximately in the first place and then to add a little bit of refinement to have a good alignment. In order to do so, we zoom in using the mouse wheel to see more clearly where the axis has to end, roughly here, and we will do this for all 4 ends of the white box. Okay. Now we have an aligned axis. However, as you can see, the number of months does not match. So here in the original image, it goes from 0 to 60 months, but in vExploder, it just goes from 0 to 1. So what we are going to do is we configure both the scaling of the axis as well as the axis breaks here at 12 months, 24 months, 36 months, and so on. This is actually important because later we will have to specify the risk table provided in the figure, and in order to do so, we have to specify the axis breaks correctly. We again use the menu symbol in the project outline and select Axis Configuration. In this dialog, you can see again the original figure as well as the axis internally used by vExploder. So we scroll down a bit and select 60 or type in 60 as the maximum x-axis value, and the x-axis step is set to 12. You can also specify the y-axis correctly. This actually does not affect reconstruction at all, but it will show you some lines here in the plot that may help with reconstruction. Now we can add a plot to the image. vExploder offers 3 methods of survival data reconstruction. The first one is the direct method. This requires the user to manually place individual events and censorings to the figure. The other 2 are iterative algorithms published by Rogula and Guyot, which are widely used in the field. In order to add a plot to an image, you click on the menu symbol in the project outline and either select Add Kaplan-Meier Direct Plot for the direct method or Add Kaplan-Meier Iterative Plot for the algorithmic methods by Guyot or Rogula. We will start with the direct plot by clicking on Add Kaplan-Meier Direct Plot. After having added a plot, you can rename it by clicking on the menu symbol here and select Plot Settings. I will just call it Survival for this tutorial, but of course this is more useful if you're having a figure showing survival of different groups. So now you can see the risk table that vExploder internally uses for data reconstruction at the bottom of the figure. We have to make sure that the original numbers at risk shown in the image file match with the internal risk table used by vExploder. In order to specify the risk table, we again use the menu symbol in the project outline and select Specify Risk Table. In this dialog, you can again see the original figure, and if you scroll down a little bit, you can see the risk table used by vExploder. Besides the numbers of subjects at risk, vExploder also supports the number of subjects censored or with an event. For this tutorial, we will not use this, and I will uncheck the Use checkboxes to disable them. Afterwards, we type in the original numbers at risk into the risk table. I recommend to use the tabulator key or the tab key on your keyboard in order to jump to the next input field quickly and more convenient. After having entered the numbers at risk, we click on Save Changes. And you can see that vExploder has stored the information in its internal at-risk table here. vExploder also shows you the numbers at risk inside the reconstructed dataset. And since we've not specified any events so far, 0 patients are at risk. This number is drawn in red because it's a deviation from the expected 40 patients at risk. So, after having configured the axis and specified the risk table, we can start with data entry. We select the pencil tool from the toolbar at the bottom, and we simply click on the canvas in order to add events. I recommend to zoom in order to have a good visual feedback. If we've placed events that do not really match the original plot, then we can move around already placed events by just grabbing them and putting them where they belong. In some plots, the lines are thicker than in others. You can adjust the line width used by vExploder lines in the View menu. Now we have the first censored observation in our dataset. We can add a censoring by holding the Control key on the keyboard, or on Apple devices, this is the Command key. So we hold the key and click again, and now a censored observation is inserted here. If you make a mistake, you can quickly revert them by either clicking Ctrl-Z or using the Undo button at the bottom toolbar. You can also redo your actions. We continue with reconstructing the data and make sure that we have a proper fit. So this section here is rather difficult. It could mess up with our at-risk table because there are several events occurring very close to an access break. However, we will have a look at this later. Okay, here we are. We have just reconstructed our first individual patient survival dataset. I recommend to always check the at-risk table once we are finished. All the numbers should be shown in green. Now we will recreate this plot survival data using the algorithms by Guyot and Rogula. In order to do so, and as mentioned earlier, we create a new plot using the Add Kaplan-Meier iterative plot option. We then go to Plot Settings in the menu and type in a suitable name and select the reconstruction method we want to employ. We will start with the Rogula method and then later switch to the Guyot method. Again, we do have to specify the risk table because the two iterative methods are dependent on having the risk table specified. So again, we go to the menu symbol in the project outline and click Specify Risk Table. When using the Guyot method, you can specify the total number of events that has occurred by clicking this checkbox and entering the number in the number field below. This may improve the overall reconstruction accuracy. However, for now, we're not going to use this. So we click Save Changes and go on. Again, you can see the internal risk table at the bottom of the plot, which should match with the original table provided in the figure. So we go again to our plot, use again the pencil tool, and specify the steps in the survival curve. Of note, you should only specify the points at the left bottom of a step and not on the top right as seen here. So I will remove this one again and go on with data reconstruction. Now we have encountered our first censored observation in the dataset. While the method by Guyot estimates censorings completely by itself, the Rogula method is depending on the user to specify any censored observation manually. So what we are doing now is we add a censoring here by holding the Control key or on Apple devices the Command key while clicking again. As mentioned, we are currently working with the Rogula method here. The censoring indicator provided by vExploder here does not have to be put exactly on the graph. Instead, it can be placed anywhere else. This may come handy in case of excessive censoring. In this case, censorings can be placed one over the other in order to see more clearly how many censorings have been inserted. I will remove these again using the undo function, and I will continue with data reconstruction. So we have reconstructed our first dataset using the Rogula method. I will now switch the reconstruction method to Guyot's algorithm. To do this, I click again on the menu symbol in the project outline, choose Plot Settings, and change the method to Guyot. Please note that the censoring indicators that I placed manually are still there, however, they do not impact the reconstruction at all, since the Guyot algorithm does not rely on manually inserted censorings. Instead, Guyot places censorings itself. In this case, this is not very accurate. However, you can see in this case that the censoring was placed rather correctly. Of note, the algorithm has no possibility to properly decide where between these two steps in the curve the censoring has to be occurred. Instead, it will place them always in the middle between the steps. As you can see in this example, the Guyot algorithm fails to properly reconstruct data, as this is a rather small dataset. However, it may be a suitable option for larger datasets as well as in special circumstances, as referenced in the vExploder documentation. So now we can save our project by clicking on Project in the top menu and select Save Project. And we can export our dataset for further use by clicking again on the menu item in the project outline and click on Export CSV. Click on Download CSV file. And here you go.